Go ahead, Philip.
All right, thanks. All right. I'm just gonna share my screen, one sec. All right. So can you see a black screen?
Yep, we see finite theory and gravitomagnetism. Looks like there's a video that you're about to play.
Yeah. Just a cool intro here, animation I want to show. And if I just want to put the nail in the coffin with what I was saying, actually, gravitomagnetism. The status bar is in my way. Just 1 second. How do we hide that status bar? Sorry about that. I'm just gonna geez. More. Yeah, the thing is I can't switch tab without the mouse, and the status bar is in my way. I'm on the Mac right now. Wow. Okay, just move that. I found a little patch right here. All right, here we go. So I just wanted to put the nail in the coffin with relativity right now. Here, I just wanted to point out that if you have one laser gun emitting a laser of wavelength X on the surface of the Earth, will the same laser gun emit a laser of wavelength X on the ISS as measured by an onboard technician? Well, if the answer is yes, then the gravitational redshift is wrong. If the answer is no, then the locality is wrong. Does the gravitational redshift is mutually exclusive with locality? Second, like I was saying in the APEC forum multiple times, the black hole are aggregates, so it refutes the wormholes and the singularities because they're aggregates. It was proven last year by a theory by Hawking that they would be aggregates. They gain in mass, so the mass is not going in a wormhole or another dimension or anything like that. Also, what defines the position of a white hole? Well, there's the definition is not available because there's no way we can define the location of a white hole. Regarding gravity probe B, that's the only question mark I have. I'm not sure. The rest sorry?
Oh, sorry.
No? Yeah, so that's the only question mark that I have. But for me, it seems impossible to measure both the geodetic effect and the lens steering effect on using one gyroscope. So it doesn't make much sense right off the bat. And as I said initially last year, regarding the light bending, it was impossible to predict the light bending without knowing the perihelion precession shift first. So these are all facts. I just wanted to grave in stone right there that it's just want to put the nail in the coffin here with relativity. And regarding finite theory, need to switch tab here. All right, finite theory. So, like I was saying last time, I talked about the earth tides. I am not going to go back on that, but basically the earth tides prove that we are within a superimposed co-moving gravitational framework, or the eighth ether if you prefer. But I'm not going to go back on that. I just want to make it more official. And the little correction to the gravitomagnetic measurement unit is that you cannot, it's measured in hertz, so it can only affect time. It's a virtual particle that can only affect time remotely. But although you can in an algebraic way, you can have a negative hertz, a negative rate. It makes no sense. So you can either contract or dilate time, but you cannot negate it. So it corresponds with finite theory pretty well. So what that means, what is a gravitomagnetic particle? What it really is it catalyzes the other particles. That's what it does, because you can find a gravitomagnetic component in the gravity, the magnetic, and the electric virtual particles. So that means you can alter and modify that component using a gravitomagnetic particle. You can slow down gravity, you can speed it up, but you cannot negate it. Same thing with a magnetic field and an electric field. You can slow it down and speed it up, but you can't really negate it. And some people didn't know what I was talking about when I was talking about the dipole stuff. So I just added a picture here. Regarding what I'm talking about when I talk about dipole fields. So it looks like that. So yeah, so that's what it is. Gravitomagnetic virtual particle catalyzes the other particles. So I'm gonna switch tab. So we all recall that spinning disk right here, that famous spinning disk that I posted a couple of times. What we see here is actually the electromagnetic Lorentz force, because you have a gravitoelectric and gravitomagnetic field, and that's going to result in a lateral Lorentz force. So now I'm going to stop the share because I want to explain what it really is. So suppose you have a gravitomagnetic field. I'm using my left hand here because it's the opposite of the right hand rule that applies to the magneto hydrodynamics effect, where you have an electric current, a magnetic field, and you're gonna have resulting force. So if you have a vertical magnetic field with a horizontal current, then you're gonna have a perpendicular force. So that is what the magnetohydrodynamics does. It's the same thing. It's the same thing with that spinning disk. You have a gravitomagnetic field. You have a current, but in that case, the current really is the the gravity, because the graviton is the carrier of the gravitoelectric field. So it's a vertical vector, and then you're gonna end up with a lateral Lorentz force. So I just want to make it clear here. So that's what's going on. Either on if the disk is counter rotating or counterclockwise or clockwise rotating, the Lorentz force is going to apply on the respective direction. So regarding that Travis-Walton abduction scene, I looked at the facts, the difference with the movies and the reality, and apparently that beam was a one-shot beam. So it kind of the beam, there was no freezing. Travis was not frozen like that. It was just kind of propelled instantly. So what can explain this is obviously he didn't go very high. If he would have gone very high, he would have gotten injured very easily. So it's just a gravitomagnetic field that put Travis in a weightless state. So he kind of he lost track of gravity. He kind of propelled him a little bit up in the air, but not very high. So because you can't negate gravity, you can only cancel it. You can slow it down or speed it up, but you cannot cancel it. And now I'm gonna talk about the it's the same thing. It's the same thing with the UAPs. UAPs, they go lateral. You know, they go lateral very, very fast. That's probably they can cancel gravity with the gravitomagnetic field underneath the spacecraft, and the lateral thrust is probably done by the Lorentz force. Obviously, you need counter-rotating this on each side of the spacecraft, or otherwise the spacecraft would spin on its own. But it's just a Lorentz force that would propel left and right a UAP. And about the force field, that's what it is. So yeah, you have a projectile coming at you. You just dilate time to stop it. That remotely, that's what you do. You emit a gravitomagnetic field that dilates time. Then the projectile is going to stop. So that's what's going on. Same thing with tractor beams. You have a beam, you just freeze the whole vehicle, the whole spaceship or whatever. You just stop time remotely. That's what you do. So it's very simple. And for the blink drive, it's the opposite. You actually contract time in a tunnel. So you have a giant laser of gravitomagnetism. You contract time, so you speed everything within that tunnel. You speed up time, you speed up speed, and you speed up acceleration. So you don't need fancy thrusters or anything like that. You just need to speed up the time. That's all you need. That's all that needs to be done to travel faster than the speed of light. It's very simple. but obviously we would need to create the tunnel first. You would need a giant device to create a giant laser beam to contract time, and then everything within that tunnel would be speeded up. And also, I want to say that it's possible to create free energy capacitors. Just quickly like that, you could accumulate like an infinite amount of energy. So it's pretty powerful. It's more powerful than an atomic bomb if you can accumulate an infinite amount of energy, and that's probably what UAPs do when they harness the sun. They go close by, they probably recharge their capacitors. So I wouldn't be surprised that's what they do. So yeah, that was my presentation. It's just 20 minutes, but it's very consistent. And yeah, thanks for your time.